to another lesson on Python programming. Today I want to just look at a program from the previous lesson, and you can see that here. And the thing that jumps out straight away, or should jump out to you straight away, is that we have two sections of code which are largely similar. The only thing that's different is in the first set we've got the variable speed, and in the second one we've got the variable distance. But we've effectively had to write this code out twice, and this makes our program longer. It means we're duplicating our code, and there is a much better way of doing this. So if I just move down and create some space at the top of the program, what I can actually do is write this code once and use it twice or as many times as I want to. And I can do that by creating something called a function. And the first thing we need to do with a function is define it. So we have the keyword def, and then we have to give it a name. So in this case we are inputting floating point numbers, so we'll call it getFloat. And that is all we need to do really in terms of defining it. We have some brackets, and then we have a colon, and then we can write in the code that we want for that particular function. So we want while true, and then we're going to have our try, and for that we're going to say we need some sort of variable, so we're going to give it a generic name. So if we call it number, and we're going to say equals float input, and we'll say enter a value. Now we have to be a little bit generic. Just make sure I get both brackets on. Then we'll have our except clause. We need to go back with that, and then we'll say number equals 0. Then we'll have our if statement, and we'll say if number we're going to do something slightly different now. So if number is greater than 0, we're going to something off. Whereas before we had a break out of our loop, now we can do something else. We can actually return from the whole function, and I'll talk about that in a second. So we'll have return number, else we're going to print our error message value out of range. And that is pretty much it for our function to input a floating point number. what this return will do is actually return back to wherever we called it. So if I remove this code now, I can replace it simply with speed, oops, typing over there, speed equals get float, and that will call our new function, and we can run that. Just close this up a little bit. So we've got our call to our function, and our function should be working. Let's just run that and just check. System, so it gives me our prompt, enter a value. So I'll say 56, and we'll have 120, and we've got our 2 hours 8 minutes. If you remember, that's what we were getting last time. So we've got a nice basic function there, and I can now replace all of this code, and I can say distance equals get float, and that will work as well. So if I run that, I can put in my 56 and I can put in my 120. But notice now that I haven't got the prompts that I wanted. Before, I was being prompted for the speed and I was being prompted for the distance. So we need to make some changes to our little function there, and we need to maintain its generic functionality. So we don't want to just have a function to input speed and one to input distance. We want a general function to input floating point numbers, but we need some way of getting the prompts to be more specific to what we actually want in. And we can actually do that. So if we go back to our function now, we can actually say, right, we want a variable called prompt. And here in the input, we will actually just output whatever the prompt is. Now, as a programmer, I need to make sure I'm doing the right thing. Now, because I'm writing the program now, it's easy for me to remember exactly what I want. But one of the reasons for writing these functions is I want to come back to them at a later date and reuse them. So one of the key things with functions is to actually make sure you document them. And one of the ways we do that is by putting in a comment at the top, and we will say what the function does. So it's function to input a floating point number. At the moment is greater than 0. Greater than 0. Our input, or better still, the parameters needed is prompt, which is a string, and you can document this however you want. It returns a floating point number. So we need to explain what the function does, what prompt we pass to it, and what it will actually return. So I've done that, and now when I use the function down here, I've got to put in prompts. So the first one was speed, so it's enter a speed in miles per hour. And then we've got a second one, which is enter the distance in miles. Okay, and if I now run this program, you can see that I get my prompt, enter speed in miles per hour. So I'll put my 56 in, enter distance in miles, 120, and I've got my output as I want it. So I've got some nice prompts coming through, so it's a little bit more usable, so I can ask for any particular number. I've set it equal to 0, which isn't necessarily the ideal. Okay, so what I want to do now is perhaps give some limits, upper and lower limits, in terms of what I would expect. And I can do that, but it means creating some more parameters. So if we just have lower and upper as parameters, so parameters I need to pass is a prompt, which is a string, lower, which is the minimum value, and upper, which is the maximum value. I can then do this the same. However, now I can change this, so I could still set that to 0, but I can actually do a check now, and I could say if number is greater than or equal to lower and number is less than or equal to upper, then I return. Now what I could do here is I don't want to necessarily set it to 0. I might want to do something like set it to lower -1. So I'm going to set it to a value that's outside the range if an incorrect value is put in. The other thing I could do is have a default value up here, and then set that to the default value. But if we just come back to here, so speed, I've got to choose a speed, so it might be 0 is my lowest one, and I don't know, 200 miles an hour is the fastest one. And our distance, again, we might have a 0, and we could have another 1,000 miles as the upper limit. So now we've got some limits put on there. If I run this code, and my upper limit for my speed was 200, so if I put 220, you can see it tells me it's out of range. If I put -1, it's out of range. If I put 30, we get accepted. Same with my distance. If I put 2,000, it's out of range. If I put 1,000, it's going to take a long time to actually travel that distance at 30 miles an hour. But you can see hopefully that this code is now working. So we've got upper and lower limits, and like I say, we could put a default in. The last thing I'll just want to look at is, if you notice here, we've put 0 as an acceptable value. The problem we'd have later on is we'd have a divide by 0 error, but if we just concentrate on the inputs, these are zeros, and it could be quite common for the lowest value to be a 0. So what we can do is say lower equals 0, and we might not have an upper value. So we could say upper equals, and we'll put some ridiculous number in. So that means that if we don't put an upper value in, it will take that as being the limit. So if I take these parameters off, so I'm not going to put any parameters in for the distance, but I'm going to say my speed is going to be at least 10 miles an hour. So we will see now that when I call get float, and this time I've got a prompt which says enter a speed in miles per hour, my lower limit is going to be 10 and my upper limit is going to be 200, because these parameters are going to overwrite these values here. When I call it for distance, when I call get float here for distance, I'm passing the prompt in, which is enter the distance in miles, but I'm not passing any other parameters. So my lower limit will be 0 and my upper limit will be whatever that value is there. Okay, so we got, what is it, 100 million? So we can see how we can actually change the parameters that we pass through. One thing I forgot to do here is the function to input a floating point number in the range lower to upper would be better. And while we're making some changes here, just one last thing I'll change. In this print statement here, I put value out of range, but we don't know what the range is. We're never telling the user what the range is. So we could actually do that there. So we could have a formatted print statement and put range is lower to upper. So there we've made a few changes. So we've got a variable number of parameters we can pass, so we can leave off the upper limit, we can leave off the lower limit, or we can leave both of them off. Sorry, I should say we could leave the upper one off, or we could leave both of them off. We've got a comment there to say exactly what the function will do. Here we're inputting the value. If the value is within range, we come out of the function and we pass back to wherever it was called what number we've input. So here we call get float, we go into get float. If we get a valid number entered, we'll jump out at that point and return it to here, and it will go into the value, the variable speed. Then we call it again, from distance, or we want distance. So we call get float, we go through, if we've got a valid number, then we will return out, and that number will go into distance. If we haven't got a valid number, it will output the range that we've got. So I'll run this one last time and we'll just see how those things work. So I've asked for the speed and I'll put in 5 miles an hour, and it says the value's out of range. The range is 10 to 200, so as a user I know that I've got to put within that range, so I'll travel at 100 miles an hour. My distance, if I make a real mistake and I put -1, then it says what the range is, and I'll put a large range in, so it's 10 hours. Okay, so we can see that we've got our function working, and we can input values, we can prompt the user, we can explain to the user if they've got the value wrong, what range they should be entering the value in. Okay, so I'll finish off there. We'll look at functions again. We'll make much more use of functions, and all our programs should be just a series of functions, really. That is the modular way of doing things. The other thing I should say is that what becomes standard functions like this one, get float, and we could do the same for an integer. You can actually put those into modules on their own, files on their own, and you can import those files so you can reuse them as many times as you want. We'll finish off there for today, and the next lesson we will certainly look at using functions again.